an arithmetic sequence. So this can be sometimes a challenging idea. The sequence talks about like a formula to help you find terms in some type of pattern. Okay, so we have like our definition list here on the right. Tn, so this is a formula that tells you the general term. The A is the starting value in the pattern, so the very first number in the pattern. The N is the term number you want to get, so if it's the 10th number in the pattern, the second number. And D is the common difference, right? And that N is like a subscript here, so that you would say that the term number, the fifth term number, if we were looking for the number 5, is some value, maybe 31, something like that. That's the idea behind this. Now, arithmetic series are very, very similar to a linear equation. Let's dive into one first and then try to make that connection after.
Yeah. What is the B kind of like equivalent to the A? Ish?
Close. It's close. Yeah. We'll talk about how they talk. Okay. So let's say we got to build a formula for this first one here. The very first term is our 12, which means that's going to be our A value. That's our first term. So when we go to build our equation, okay, you're going to have Tn is equal to 12. Okay. Plus n, because it depends what term number we're looking for, so that doesn't change or anything, minus 1. And then the common difference. Well, we need to find a common difference. So you essentially take, figure out what it's increasing or decreasing by. This one's clearly increasing, and it's by positive 3. So the common difference here is the number 3. So here's your formula to find your stuff. Now, the only difference is if we were looking like y equals mx plus b, your m would be the common difference. It's the slope. It's what it's increasing by. So that would be the positive 3 value. The problem is the a and the b are not the same idea because that's the first term. So that's when n is equal to 1. Okay, that would be 1. But b is a y-intercept, which is when n, or if it was an x value, would be equal to 0. So we'd actually have to pull it back 1. So if we were to go back 1, what would the b value actually end up being here?
9.
Yeah, it would be 9. Okay. So for the way we're used to seeing it, in a linear equation, this would be our equation here. Okay, we would have, we'll write it in. We would normally have y equals 3. I think I write that in blue normally. 3 x plus b, and b was, what did we say, 9?
Yeah.
Yeah, 9. Okay. Let's actually go about distributing this formula here, okay? So if you remember distributive property, I don't know if you recall it, but this 3 technically needs to be multiplied by both those terms, okay? So the term number is equal to 12 plus 3n minus 3, okay? And then our like terms are 12 minus 3, and what's 12 minus 3?
9.
Right, so we get 3n plus 9. Okay, so the reason they write it this way is so that it's very simple to see what the term number is and what it's going to be. But this is just the linear equation. That's all it is. It's just broken up a little differently for us so we can see what the first term would be. And if we look, if we go into like a graphing calculator here, if we were to write 3x plus 9, and we were to zoom out, okay, 0, 9, that doesn't exist. But we know that 1, our first term being 112, that was one of them. The second term for us was 215, that falls on our line. And the third term here was 18, right? Now, the difference with an arithmetic series is there isn't like a 1.5 term. They don't really talk about that. Where in linear equations, we can find a value at 1.5. We can find anything on this equation. These are usually just built with integers because we don't talk about the 1.5 term. We talk about the first, the second, or the third term. So using this equation now, because using a linear equation, we wouldn't be able to do this next little thing we're about to do. Let's say I want to find the 8th term. I shouldn't say we can't. We could. Let's say I want to find the 8th term. So I'm looking for the term value of number 8. Well, I write in our 12 plus 8 minus 1 times 3. That's going to be 7 times 3. So that's going to be 21. And that's going to be 33. So the 8th term number should be 33. Let's go to our graphing calculator. If I were to say x equals 8, okay, and zoomed out a little, we're at our value. Whoops, it's 33. So that's exactly how it works out. It's the exact same thing. It just allows us to choose a specific term number to use, okay? So with that same idea, we'll quickly build the second one.
All right.
If we wanted a term number, what would our starting point be? What would our first term be?
5.
5. Okay, so there's our first term. We have 5 plus n minus 1. And what's the common difference here?
6.
Yeah, is it increasing or decreasing by 6?
Decreasing.
Okay.
So it'll be negative 6?
Exactly.
Okay.
So it'll be negative 6. So you're multiplying by the value, and maybe I'll write it like this, of negative 6. So if we were to build a linear equation of this, let's say we do it on the side, we know that the common difference is the slope, right? So we're going to have negative 6x. What would our b value be?
Plus 5? Or
Remember, it's always the
Oh, yeah,
number.
plus 4, plus 4.
Yeah, it would be the 0. So we'd go
no.
back.
6.
Yeah.
Yeah, so it'd be plus 11.
Positive
Oh, okay,
11.
yeah,
So it'd be
yeah.
plus 11. And if you were to FOIL that all out, you would get that same linear idea. Okay. So these are really linear equations. They've just broken into a way so that it's easier for us to see things. So don't think it's like something we've never seen before. It's just not commonly related to a linear equation.